So tonight on our Corsa meetup, we're going to talk about the stock drum brake system that came on your Corvair or Corvair truck. I know there's some people that say, I've been putting brake shoes on my car since 1959. I know all about drum brakes. Well, maybe you do, maybe you don't. You might learn something. Certainly, there's people who have been doing stuff longer than me. And anybody who says they know it all, that's, I won't use the word, but nobody knows it all. But hopefully I can let you know a little more at the end of this session. So let's take a look at, I'm going to give a little example of the Corvair brake system and the differences there are, because a drum brake is sort of a drum brake, but the actual application as we see it on our Corvair is not all the same. There was a bunch of different changes they made over the years. So we'll start with the very first one here, and this is an ordinary drum brake setup as used on the 60 and 61 cars. Just ordinary. It's just got two shoes, and you'll note on all brake shoes there is a primary and a secondary shoe. The primary one is our first shoe, our front shoe. It's thinner, and our secondary one here is a longer shoe. Okay, that's by design. And on the 60 and 61, it simply had a star wheel to adjust the brake shoes and the wheel cylinder. And that's about it. Now, normally this wheel cylinder would be straight, but our anchor bolt is off because it's not connected to anything. We don't have any spindle in here. So this is an ordinary type of brake and is common for all the GM cars of the period. They all use pretty much the same style. Of course, the shoes on the Corvair were specific to that car. They don't fit, the 60 and 61 shoes don't fit other Corvairs.
I guess you can. Okay.
All right, so that happened. And then in 1962, the shoes were revised. And the thing that was revised on them is actually they look exactly like this because these are 62 style shoes. But the 60 and 61, where I have made a black mark on the very top of this shoe here, you might see that. An extra plate is welded on in this area on both shoes, and that's a reinforcement for the parking brake hole, where the parking brake lever, that's this guy, the parking brake lever goes into this hole here from the back side. And in 60 and 61, this lever has a longer pin on it. It's twice as long as this one is because it goes through two layers of the metal on here because it's reinforced. So in 62, they decided we don't need that reinforcement, and they just left it off. So there's just a hole here. And then, of course, they revised the parking brake lever here to be the thinner style. So when I push it through, it's just got enough room on it to put the clip on the end of it. So that's the 62 style shoes. Otherwise, things were the same, except for the new extra cost, extra performance metallic brake option that became available in 62. Most commonly seen on Spyders because it was a recommended, in fact, at the very beginning when they started to sell Spyders, it was a mandatory option. You had to buy the posit traction, you had to buy, of course, the Spyder package itself, but the 4-speed, the posit traction, the heavy duty suspension, the metallic brakes, and seat belts. Those were all things you had to buy. And then they kind of rethought that before the cars really went on sale and decided, well, no, you really don't have to buy that, all that extra stuff. But most 62s got ordered that way. And these are the kind of brakes that you would have had on those 62s with the metallic option. These are very special brake shoes. That's a Delco Moraine product that they made, and it's basically a racing set of shoes. It's a metallic, not an asbestos type lining, and they were not these, of course, are specific to the Corvair, but they were also available for the full-size Chevrolet And it was announced anyway, the 61 Impala Super Sport with the 409 would come with metallic brake shoes as well. And of course, they had been available on the Corvettes. It was a way to have the Corvettes have some competitive brakes in, performance driving. Okay. But it also showed up surprisingly to the Corvair line. And we'll talk a little bit more about the metallic shoes, but they were a factory option. In 63, all the GM cars used a new thing, self-adjusting brakes. That's what all these extra levers here and rods and a few other things are on here about the self-adjuster. And the style of the brakes is not Corvair specific. This is the same as on almost all the GM cars, 63 and later. And the way this works is now some of these parts are left and right hand on the car. So all our self-adjusting parts, our lever here, our actual star wheel, these parts are specific to the left side or the right side of the car. And the way it works is when our brake shoe has a lot of travel, it moves pretty far. When it moves pretty far, you see this top link here is a fixed point between the lever and the anchor pin. Okay, so when the shoe moves far away, it pulls this lever downward, and that in turn turns the star wheel to widen it. So it adjusts the brakes until the point comes when you step on the brake and it doesn't move very much, and therefore doesn't move this lever. That's how it's supposed to work. Now in this one, like any car that's been sitting around, it hasn't been turned in a while. It's kind of rusty. And is this thing going to turn? No, it wouldn't. But if everything was nice and cleaned up and lubed, yes, by moving this lever against the star wheel, it would spin it and adjust. And like I said, the star wheels are now different left and right because one of them's threaded one direction, and on the other side of the car, it's threaded the other direction to make it work properly. So when you're taking your brake parts apart on a self-adjusting car, don't throw everything into a big bucket because the parts are not the same left to right. Have a right bucket, have a left bucket, okay? The other thing they did when, that may not be immediately obvious, is the brake shoes changed in 1963 again. In 62, they got rid of the reinforcement lever up here by the parking brake hole. But in 63, because of the new self-adjusting mechanism here, they had to have a pivot point so that the self-adjuster could pivot back and forth as it moved. And in order to make that work, previously, the holes in the backing plate here for the earlier brakes just needed a hole for the pin to go through to hold the shoe down. But now, in 63 with the self-adjusters, they had to accommodate this lever. So what they did is they made a larger hole in the shoe. And I'll just put the two of them here together. This one's from a 62. You can see the little hole, and this one's from a 63. Big hole, little hole there. And that's the difference between the 62 and 3 shoes. That's the only difference, really. If you found in a swap meet a set of 62 shoes and wanted to use them on your 63 car, no problem. You can just drill that hole bigger. But with the bigger hole, now we can get our lever in there and it pivots like it's supposed to. So that's the 63 style brake. 64 models continued exactly the same as 63. The 63 and 64 Corvair brake shoes are the same basically as the 62 and 63 Chevy 2 use those same brakes. Okay, and again, the 62 Chevy 2 is manual adjust, just like the Corvair. In fact, the Corvair brakes shoes are identical in 62 on the Chevy 2 and the Corvair. So that's the differences in the early model cars. Okay, moving on down, and we have the Corvair truck. Now, the Corvair truck, of course, bigger vehicle, a commercial vehicle. The shoes are much bigger diameter, but the principles are just the same as they are for the Corvair car. So this is a early one, a 61 or 62, and it's the same setup, just larger parts. The springs are bigger, the shoes are bigger. And of course, the drum is a different size, the overall diameter. And again, in 63, they went to the self-adjusting mechanism, and that remained the same for the rest of the production of the Corvair trucks. These shoes on the Corvair truck are the same size as used on a lot of the Chevrolet passenger cars on the rear. So, these Corvair truck brakes are the same as a 66 Chevy Impala, on the rear of the Impala. So good availability of the brake shoes and parts, because there's millions of those cars made. Then in 1965, of course, we had the new design Corvair, and with that, we had a lot of improvement in the braking area. So for the first time, the 65 Corvair had different size brakes, front and rear. They were the same diameter, but the rear brake shoes are wider on the back of the late model Corvair than it is on the front. And these shoes that were used are the same shoes as they had started to use on the 1964 and later Chevrolet Chevelle and the companion cars, the Buick Skylark, the Olds Cutlass, and the Pontiac Tempest. So the bigger, heavier cars were using the same brakes as the 65 and later Corvair, except that they switched ends. In other words, the Corvair, the heaviest end, is at the rear of the car, and obviously on the more conventional Tempest and such, the heavy end's is in the front by the engine. So the brakes that are used on the front of those cars is what's used on the back of the Corvair. And that gives the Corvair a nice advantage that it's got, the 65 later has got, for the period of time, wonderful brakes when everything's working right. Because the car stops nice and flat, and you've got brakes that are really oversized for the size of the car. Imagine the same brakes are on a big block Chevelle in those years on a car that weighs much more than the Corvair does and is not as well balanced at all. So its braking system's really pretty good. As far as the layout on the 65 and later Corvair, it's identical to that of the 63 and 4 Corvair, the same type of parts, levers. Obviously, the springs are going to be different because we have different size brake shoes, but the main parts are very similar in the setup. The 65 and later stuff is really easy to get because it's used on so many of the GM A-body cars like that. So all kinds of pieces are available for the 65 and later. Not so much the earlies. When we talked about the differences in the brake shoes, there's a one-way interchange on that, and that is the common brakes, common being relative. The 63 and 4 Corvairs use a number 189 brake shoe. That's the industry number for them, a 189. And those shoes can be put onto a 62 Corvair that doesn't have the self-adjusting mechanism. And they can also be put on the 60 and 61 Corvair, which doesn't have any of that stuff in here, but those 63 and 4 shoes will fit right on here fine. They'll work fine. Now, it doesn't have the double reinforcement on the parking brake lever, but apparently the factory didn't feel that was necessary because they removed it later on. So your later shoes will fit on here. The pin will stick out a little bit further, but that's okay. It's not going to hurt anything. So the 63 and 4 shoes are the ones that are commonly available. If you try to find these, the number 111s for the 60 and 61 car, probably the only time you're going to find some is a new old stock replacement set somewhere on eBay or at a swap meet, something like that. That's not going to be common. But you cannot put those 111 shoes onto a later car because the parking brake pin is going to be different and you're not going to be able to keep it in place. So it's a one-way swap. Still gives you an idea. Next, the hydraulic end of things. Let's take a look at first the master cylinder. When you're in the trunk of a 60-61 Corvair, that's all you see is the plug for the master cylinder where you fill it inside the trunk. Everything else is inside the car, up above your feet. That's the master cylinder and the push rod and the pedal and all. So this is all hidden underneath, and you really don't see this from the outside. So it's a 1-inch bore. All the Corvairs except the metallic brake cars used a 1-inch bore master cylinder. So this is 6061 only. Starting in 62, they brought out a new design master cylinder, which was shared with many other Chevrolet products and other GM cars as well. The difference is in the outlet of which direction the brake pipe came out. On a Corvair, it goes out to the left side. Some of the cars have the brake pipe coming straight. Some of them have it coming to the right. Some come in the top. Different locations on the outlet, but otherwise pretty much the same master cylinder. And the 62 and 3 Corvairs use this thumb screw on top. That's how you get it off. It's not a bail clip like you might be used to seeing, but a thumb screw is the correct one for the 62 and 3 cars. Starting in 64, again, they went to the one you're probably familiar with the bail clip on top. You just popped it off with a screwdriver, and that's it. Now, this one is a later day replacement one because it has a bleeder screw, and you see it has the port that's normally used on the Corvair, but they also drilled and tapped the front port as used on some other Chevrolet and GM cars, and they put a plug in there, and you can see it's also got the boss for a fitting on this side, depending upon the use. But the fitment is all the same. This later style, that's my Milton driveway signal, by the way, binging away back there. Every proper old gas station repair shop should have one. This style master cylinder, it's commonly available. They will fit the 63 and 62 cars. It's just a bolt on, so it's no problem at all to do that. One thing I would highly suggest that you check, and usually you don't have to do anything about it, but whenever you replace a master cylinder, I'm going to bring back my friend here, the 6061, because we have the pedal set up on here. And that is right here is the block where your pedal is. And this is an adjustable push rod. And you should check to see the free play from the pedal to the master cylinder. In other words, right now, when I move the pedal, I'm just moving it a little bit, and I can feel when the push rod is touching the piston inside. It's moving about that far, tiny bit, when I move the pedal back and forth. The cylinder absolutely must return all the way to the idle position for the cylinder to release all the pressure. If the brake cylinder is down a little bit, it's not going to release the pressure, and you'll be driving and your car is going to be getting slower and slower and slower until smoke's pouring out of your wheel wells because the brakes have been on. Okay, so it's real important. Theoretically, all the replacements should have exactly the right depth, but don't take that for granted. You just want to make sure you got a little bit of play there. If you didn't have a little bit of play, or you had too much, say your pedal moved like a ½ inch before you could feel it contact, you'd want to loosen this lock nut, and then it's got a nice little knurl on the shaft here, and you can use a pair of pliers to just turn this to make the adjustment and then tighten your lock nut. It's very simple to adjust the push rod on here. You do that now. Yes, you're going to be upside down underneath the dashboard doing this, so easy is relative, but you do not have to remove the master cylinder. The setup is the same regardless if it's a 61 or a 69. They all have an adjustable push rod. It is not bad to get at. So always check that. Always check that. 67, the safety feature, the dual master cylinder. Everybody thought this was great, but really you know, it came out in 67 as standard equipment on pretty much everything. But they'd been around for a while. Two manufacturers, American manufacturers, introduced it as standard equipment on their car lines in 1962. Can anybody guess who those two guys were? I hear you all thinking. Well, Cadillac might be an obvious choice because the premium GM car, and they would, you can certainly afford to do a little bit of inexpensive features on a car like that. It's built into a price. So yes, indeed, the dual master cylinder became standard on 1962 Cadillacs. But the other company might surprise you. American Motors and Rambler. Yes, sir. All the 62 Ramblers had dual master cylinder on them as standard equipment. And the following year in 63, it was an available, actually, it was available on all the 63 standard on all the 63 Studebakers except the very cheapest Lark style car, the standard. They called it the Studebaker standard. It still had a single master, but you know, the independents actually got a little bit ahead of the game before everybody else did. The dual master cylinder was a special limited availability option on certain 66 Chevrolets. It wasn't really in the book per se for Corvairs, but that is how Don Yanko got them installed on the Stingers, because it was a limited production option, and they were using the Cadillac master cylinder because that was the cylinder that was already in production. It didn't take a great deal of effort to put that dual master on. Now, the dual master, I want to talk about that a little bit. And this is all the plumbing that you'll see underneath the hood of a 67, 8, or 9 Corvair. And you see, we got the two outlets, we got this block here, and it's got a wire connection, a switch on there. And then we come down to our lines, which go inside the car, two separate lines. One of them is going to both front wheels, and one of them is going to the back wheel. Okay, that's how we're splitting the system. First off, this thing here, this block. I've heard people say, well, it's a proportioning valve and it makes the difference between the front and rear pressures. I've heard them say, well, when one of your brake lines go out, there's a little valve in here that moves over and shuts off that line so you can't lose any more of the fluid out of there. It's none of those things. The only thing this does is when you get a failure on one side of the system, or let's just say you just ran out of fluid, not even necessarily a failure, you never checked it, and it ran out of fluid, it pushes the one side, whichever side is not working, away from its normal position. It grounds the circuit on the switch, and it turns on the brake light on the dashboard. Now, believe me, if you ever had a brake failure on your car, you don't need a light on the dash to tell you that something is wrong with the brake. You will know in a nanosecond that something is wrong. Okay, but you know, don't be fooled into thinking this is more than it is. It's simply a switch for a light bulb. That's all it is. Okay. Anyway, the dual masters are great. Came on 67 and later Corvairs as standard. Again, 1-inch bore. All the Corvair master cylinders use a 1-inch bore except the spider option with the metallic shoes. That was more than just the shoes. It included the segmented shoes that we showed you, and the master cylinder was a 7/8 bore, and also the front wheel cylinders, which were normally 7/8 bore, moved up to a 1-inch bore. So what that was doing, the smaller the diameter of the master cylinder, the more pressure it has. For a given amount of foot pressure, it makes more hydraulic pressure. The downside is you have less motion because the cylinder is smaller, so you would have to step on your brake pedal. It would travel further to apply the brakes than the 1-inch style. And by increasing the wheel cylinder size, it gave more braking force on those front wheels. So it's it was more than just shoes for the factory option. So that was it on the metallic brake option. So with that in mind, I know a lot of people talk about doing a, let me just check, see if I'm online here. We'll get into a dual master cylinder conversion in a little bit, because I know a lot of people like the idea of having the dual master in their car, and it does have some safety benefits if it's properly done. And we'll get into that because that's the important part. Okay, self-adjuster, backing plates, blah, 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 blah. Okay. They did make a couple of changes on the wheel cylinders, of course, over the years. Now, 60 to 64, each wheel cylinder is different. It only fits a Corvair. That's all that wheel cylinder fits. It doesn't fit any other kind of vehicle. And the front wheel cylinders for the metallic brake option are different because of the bore size. Physically fitting and bolting up, they will to any front, but they are the bore is different. 65 and later, again, every single wheel cylinder on the car is specific to that location on the car, and they are Corvair only. So if you think, oh man, I busted off a wheel cylinder screw, I'm going to go down to AutoZone and get me one. Forget about it. You're wasting your time. They're not going to have it. You know, they might think they can have it. Oh, we can order that for you. They can't. It's a Corvair specific item. Okay. But one thing that is even more specific is if you have a 69 Corvair. Now, they only made 6,000 of them, but you'd be surprised at the number of changes they made on that model year, as short as it was. And one of them dealt with the brake system and the wheel cylinders. All the regular Corvair wheel cylinders have the hose that just screws into the end of the wheel cylinder. Not on a 69. It's got a little pipe that comes out of the end of the brake hose, and that fitting, it's a much smaller fitting, screws into the end of the wheel cylinder, which also means the wheel cylinder is different because it doesn't have the big fitting that all the rest of the wheel cylinder hoses have. And on top of that, there's a little bracket that bolts to the backing plate, which holds the end of this brake hose in place to line it up with the wheel cylinder. So there's a surprising number of changes in the front brakes. As far as functionality, it's the same size bore. It doesn't make it stop any better, but I think this probably had to do with some sort of federal regulation on a brake hose placement and routing. Otherwise, they certainly wouldn't have bothered to do it. These are available as a reproduction from Clark. So if you've got a 69, you can get the right stuff. If you are so inclined, the 65 to 68 hoses and wheel cylinders will bolt right on instead of the 69 stuff. Just saying. So that's a little bit of variation on the 69 models. I'm not going to tell you how to replace brake shoes. Like I said, you know, a lot of you guys were replacing brake shoes on your cars for decades, and there's nothing special about a Corvair. But I wanted to talk specifically about a few things that kind of go along with the brake replacement that maybe you didn't give too much thought of. One, of course, is we talked about the primary and secondary shoes. The short one always goes to the front of the car. Always to the front of the car. If you look at the shop manual, they'll show you a picture of that brake. And so you put your brake all together, just like in the picture, and then you went around to the other side of the car and you put it just like the picture on the other side of the car. Well, guess what? This one is only right here. We're looking at the right front here. If you put it exactly the same on the left front, now your primary shoe is going to be in the wrong spot. It's going to be in the secondary position, not the primary position. So always little short shoe to the front of the car, big shoe to the back of the car. Okay, so that's one thing. Another thing is there's a friction point, these little shiny spots on my very rusty brake drum, 3 on each side. That's where the shoe actually rides. The edge of the shoe rides against here when it's moving back and forth. Okay, we want to lubricate that spot with just a little bit of very high temperature grease. I use what's commonly called caliper grease. You do not want to use like chassis grease. I got the grease gun here. I do my ball joints, everything with. I'll just use a little bit of that. Don't use that, because when it gets hot, it'll start to drip. and it's going to drip down here and it's going to get on the brake shoes. Greasing the brake shoes is a bad thing. Okay, so use a really high temperature grease. Like I say, the what's commonly referred to as brake caliper lube or, is a good product to use on that. And just a little schmear. I've had cars in the shop where somebody says, I'm going to grease these up, and they put a big dab on there. And that big dab, of course, migrated onto the brake shoes. All we need is a little film on there to make it so it's got a little bit of lubrication. And that's all we need. Don't glop it on there. Okay, so don't forget to clean and lubricate these. In fact, this one, just came out of my trailer at Junk Parts, and that's what this is. I would probably try and grind this down so it's nice and smooth. You see, this got a lot of pitting and everything on here. So we'd want to try and make those areas as smooth as we can so we don't have any rough spots. The other thing that we want to talk about is adjusting the brake shoes, because this is a really important part of getting the brakes to work properly. Okay. Now in 60 to 62 models, they did this externally. This is pretty easy. There's a slot on the back side of the backing plate on all four wheels, and this oval slot, and right through that oval slot is our star wheel, our adjuster. So let me just walk over here and get my adjuster tool. Now this is actually a brake adjuster. It's kind of like a bent screwdriver. I'm sure you probably got one or two in your toolbox. Even if you don't, you can use a regular screwdriver. But remember, when it's assembled on your car, we've got our lower control arm and our steering knuckle and everything. There's a lot of stuff going on in the front suspension. It may be helpful to steer the car to one side or the other so you can get at that hole a little bit. And you just put in whichever end fits in there better for you at the angle you're at, and you make your adjustment. Okay, you click it, just keep going until, and this is important. Now, Shells, you may have to turn around for me here. Now, in 63 and later, of course, with the self-adjusters, why would you have to adjust the brakes? They're self-adjusting. Well, don't believe that, because first time around, you have to set up the adjustment of the brake shoes. Okay, you can't just use the self-adjusters to make the initial adjustment. So your brake drum is going to have a knockout on it. If you see this little oval spot here in the drum, looks like an oval. Just take your air chisel or a hammer and chisel and just boink that thing right in. There's usually two of them. They're 180 degrees apart from each other. And that's what I've done on the bottom here. I've knocked the knockout out. Okay. So with that, I'm going to slip my drum on. And I'm going to find where my adjuster is. And of course, we know it's already at the bottom here. But if I stick my adjustment tool in here and turn it till it hits it, I know, okay, I'm right there. So I'm going to adjust it. And on the self-adjusters, when we spin them down, that tightens it. When we turn it the opposite way, when we move the tool up, to spin that back, it's going to loosen the brakes. So what we want to do, drum on, and we want to tighten the brake until we can't turn the wheel anymore. I can still turn it there. All right, I can barely turn that. Okay, why do we want to do it like that? Aren't you supposed to tighten it until you get a little bit of drag? Well, yes and no. I'll tell you why in a moment. First, I'm going to back this off a little bit so that I can get it to turn. That's still a little tight. I'm going to go backwards a little bit more. Okay. Why do we turn it so tight to begin with? If one of our brake shoes was dragging when I was tightening it, we wouldn't want to rely on that as having the brake shoes centered on the brake drum. If such as say the shoes were knocked over, like I just bumped them over there, okay, or bumped to the other side, whatever, one shoe's going to be touching the drum, the other one's not, okay, if I didn't have it adjusted up. So if you try and adjust it a little bit and you feel, oh, there's a little bit of drag there, that's okay, we'll be good. If you don't know that the shoes are centered and that the drum, that they have the same amount of each contact, you could be seriously unadjusting your brakes. In other words, they're not adjusted enough because only one shoe is dragging. So that's why we want to adjust it until we can't turn the wheel anymore. That way both sides have equalized themselves within the drum so that we got equal contact on both sides. That's why we want to adjust it all the way out first till they lock up and then back it off. Now, you've also seen that this has the little self adjuster here that it normally, if it's out of adjustment, it'll spin the adjuster down. But when I'm trying to turn it backwards, it's going to resist turning because it locks this up. Now, I was able to overcome that just by kind of forcing it, and it popped this loose. But if you're having a hard time with that, you can use a little kind of hook tool, something like this, and put it in the same slot and pull that back. So I'm going to show you how to do that. It's just like I said it was. So let's put our shoes back on. So first I'm going to get my little hook tool. I'm going to find where my self adjuster is, and I know right above it is going to be my there it is. Of course, you got to do this one by feel because you can't see in there. All right, I got the spring tension right there. I can feel it. Now, if I hold that back a little bit, I've pulled the adjuster wheel away, and I can just spin that easy as can be. I can get any very fine amount of adjustment I want. And now I've unadjusted it quite a bit, so this will just spin like crazy. That's way too loose. But you see how you can back it off with a simple little hook device like that. And that's pretty easy to do. Okay, so we want to make sure that we've adjusted our brake shoes. Remember, so they're locked up or super heavy drag. That's locked up. And then we back it off. Too tight still. Still a little too tight. That's good. That's good. This is loose enough. It still has a little bit of drag, but it's loose enough we can slide the drum on and off. If you can slide the drum on and off without trouble, you're okay. But we don't want to get the brakes real loose. We want to have them, you know, reasonably close like that. Okay, so that's the important part of adjusting the brake. Now, we're going to look in the back here, because in the back of the car, of course, we got a couple of other things going on, and that's the parking brake mechanism. Okay, well now we're at the back of the car, and our back brakes have a couple of extra pieces in them that our front ones didn't. So it makes our few extra things we need to look at during adjustment of it. And that has to do with the parking brake. Of course, parking brake's real important on a Corvair, especially an automatic car, because we don't have a park position in the transmission. So we have to rely on the parking brake to keep your car from wandering away. All right, so those extra parts are the basic brake assembly here, and this is from an early model, but don't let it bother you because all the setup is about the same. We have a parking brake strut, a lever, a little anti-rattle spring, and the parking brake cable itself. I got out that rusty example because it's easier to see because there's no hub or axle here. But these are the actual parts here. This would be one from the left side of the vehicle. So the struts are different to this series of cars. In other words, early model is different than late model and different than truck. And same with these levers here. The anti-rattle spring is also different early and late, okay, due to the diameter of it. But these make up the pieces for your parking brake, and what happens is when you pull the parking brake cable, it makes this strut move forward, and that in turn pushes our front brake out, our brake shoe, and makes contact with the drum, and that's what makes our car stop when we put on the parking brake. So I'm going to go back to our car here, and we're going to go ahead and take off the drum so you can see the pieces inside. And I'm going to pull on the parking brake so you can see what happens when I pull it on. It's going to expand the shoes out a little bit so that they're going to contact the drum, and that of course is what makes it function. Okay, so you just saw that our shoes moved out, and of course they're no longer contacting the anchor pin on top, and that's correct. That's what's supposed to happen. Now this can screw you up if the system is not working correctly. Okay, when we go to adjust our brake shoes, we have to have the parking brake fully off, and our shoes have to be in their normal position, which is with the top of the shoe resting against the anchor pin. This is very important. Okay, so when we go to adjust the brakes, make sure that the shoes are all the way against you. If the shoes are not against the anchor pin, you're going to get a false adjustment when you go ahead and move the star wheel underneath. So what can cause this to not be able to go back to the normal position of against the anchor? And that could be a couple of things. Some of them have to do with the parking brake. Of course, the first thing would be if the wheel cylinder is stuck. If it has a piston that's stuck and can't release, then of course you won't be able to retract the shoes all the way. If you have a brake hose that's gone bad and is turned into a one-way check valve, so it doesn't release the fluid all the way, it's not going to let the shoes come all the way back. And of course the other thing is if the parking brake cable is either misadjusted, it's adjusted too tight, and the strut here has tension on it, it'd be holding the shoes apart. Or if the cable itself, the one that goes from the left side here to the right side in front of the transmission, there's two cables, remember, there's one from the dashboard pull lever that goes from there to in front of the transmission, and then there's the one that goes from the left wheel to the right wheel, and that's our cable, goes underneath here and goes side to side. On a Corvair truck there's a separate one for each side in the back, but on cars it's one cable for the rear. If that cable is rusted in position, either it can't pull, or if it pulls, it happens once and now it's stuck in the on position, and that will also keep tension on the strut here and not allow the shoes to retract all the way. So very important before we go to adjust the rears to make sure that the parking brake cable is free. You could try it just like I just did by pulling the parking brake to the on position and seeing that the shoes spread apart, and then after you release the parking brake cable you should be able to push them back together like I just did. Of course, in actual operation on the car, they're not going to spread anywhere near as far as I did when I pulled the parking brake cable on. They're just going to move a little bit because they only have to move that far to make contact. But as a good example, like I say, they should spread apart, and then when you release the cable you should be able to push it back together. If you can't, something's not right. So check to see that the rear parking brake cable is free, that it will move in and out, and then if it does move freely but they're still not coming together on top, the parking brake cable adjustment that's the front cable. It's threaded at the very rear in front of the transmission. You may have to move the cable, turn both the nuts on there to release tension on this rear cable, so it allows the cable to come back further and release tension on the strut. Okay, that's very important before we go and put our drum back on. We can get it here. There we are. So we can go and put our drum back on and then use our adjuster to spin the star wheel and back. Now, if your car happens to have the extra cost, extra performance posit traction option, what's going to happen is when you turn one rear wheel, either side, doesn't matter, it's going to want to turn the other side as well. And that's going to make it a little trickier to adjust it, because now you've got twice the amount of drag that you would normally. So it makes it harder to feel when you're just getting in the right position. If you happen to have the other side of the car still on the ground, say you're working on one side of the car at a time and have only one side jacked up, it's okay to do that. But if you got posit traction, you are not going to be able to turn this brake drum on one side of the car because the other ones can't turn at all. It's on the ground. So keep that in mind. What I would suggest, if you happen to have posit traction, is to take off the brake drum on one side of the car, go ahead and make your adjustment on the other side with the brake drum, and then when you come back to this one, do the same procedure except opposite. In other words, you're going to put the drum on over here, take the other one off, and make your adjustment. That way you're not feeling the drag of the other brake drum when you're trying to adjust this one. So it's a little extra procedure that you have to do, simply because that's what happens when you have that you check off that box G80 posit traction on the order form. So it's important then to make sure, like I say, the parking brake's fully released, shoes are against the anchor pin, and then you can make your adjustment on the shoes. Once you make the regular shoe adjustment with the star wheel to the drum, then you can properly adjust the parking brake. What we want to have happen is when we pull up on the brake lever at the dashboard, we want it to go no more than halfway of its travel, so when it gets tight enough that it's going to hold the car from rolling. So that's our proper adjustment on it. If you've got to pull your parking brake all the way up to near the top to get the car to stop rolling, that's not right. So when you go to fix that, the first thing you do is adjust the shoes by the star wheel, not the parking brake first. If you try and adjust the parking brake first, you're going to end up with that problem of the top of the shoes not hitting the anchor pin. Okay, that's wrong. You need to adjust the shoes first and then the parking brake travel. All right. How to bleed the brakes. There's lots of different ways. You can buy all kinds of tools for it. Important thing is to start with the wheel cylinder that's the furthest away from the master cylinder, so we get all the air going through the lines. On an early model, that's going to be the left rear wheel you do first, the right rear wheel next, right front, and then left front. On a late model, it's going to be the right rear wheel first, then the left rear, then the right front, and then the left front. So you just go with the one that's got the most amount of line going to it, the longest distance, do that one first. And the shortest one, which is always the left front, do that one last on the procedure. So we talked about the basics.
Hey, Larry?
Yes.
There was one question that just popped up. Is it any different when you're just bleeding the brakes for an FC? Anything different for FC?
Yeah, it's more inconvenient because you got to keep checking the master cylinder underneath the floor. But other than that, the procedure is the same. You do it the same way. And on the forward control, the right rear is the one you should start with because it's got the furthest distance you travel from the master cylinder. But otherwise, the procedure is the same. It's just, you got to keep the master cylinder is not as convenient to get to. That's all. And you got to be careful of where it's at, not to get dirt and stuff in there because you're going to have the cap off and it's you got to be careful with trying to keep the thing cleaned up in there. So that was the areas I want to touch on to make sure you're doing a proper assembly of the brakes. I'm not going to tell you how to put the springs and shoes and all that stuff on because you probably know all that. But the little tips there, I hope, were helpful. Now, the important thing that I wanted to present in this presentation was that I've often found that, you go and get some new brake shoes, whether it's, you get them at Napa or AutoZone, whatever. You put them on, you rebuilt the wheel cylinders, you bought a spring kit, you put it all together. You had the guy turn the drums. You think, man, I'm going to have new brakes. This thing's going to be great. You put it all together, you drive it down the street, you step on the brakes, and you think, Jesus, I really got to step on the brake to make this thing stop. It's not what I expected it to be. And then, your buddies tell you, well, you got to let them brakes, break in. They got a seat to the drums and, it'll be, you just got to drive it some more. And so, 500 miles later, you're still thinking, gee, I wish these brakes would stop the car a little better. There's an answer for that. So we're going to take a little road trip, and it may be enlightening to you, and it'll answer some of your other questions too. So in this presentation, to help fully explain how to get the most out of your drum brakes, I'm taking a road trip to Fort Wayne, Indiana to visit Scott Bethke at Brake Materials and Parts. This place has been in business since 1936. Scott's been there since 1984. It's rather unique in that brakes is the only thing that is sold or serviced here. So the common thing that happens is somebody goes down to the local parts store, Napa, AutoZone, whatever. If they can buy brake shoes there, they get a new set of shoes, they rebuild the cylinders, bleed the brakes, put everything back together, and the first time they take a test drive, they think, Jesus, this thing don't stop. It's standing on the brake pedal trying to get this car to stop, and it's not working. And they become discouraged and say, I got to get a disc brake conversion for the car. And that's really not the answer.
Well, not if you want to keep it original.
Right.
A good brake, you should be able to modulate. You should be able to get just a little bit to full lockup, and you should have full control. And that's what we'll talk about today, how to do that.
Okay, great. Show us around the shop here a little bit.
Yeah, I'll give you a little bit. We got some parts.
Some stuff.
Occasional parts.
Yeah.
But the real mystery, the real magic happens in the back. And we'll just take a quick tour. We're not give too many secrets away. All right. We do everything here from 1900s to modern day, from tractors, go-karts to big cranes.
Anything with brake lining, right?
Yeah, pretty much. So we take the shoes, we tear them down. If they're steel cores, we'll burn them, blast them down to bare metal, then we'll reline them, and then we'll paint them with a rust-inhibiting paint. And then, of course, we fit them to the drums, which is where the magic happens.
Right. I'm looking at some of this equipment, and I expect some of this might be older than me.
Could be.
Could be. No. Could be.
Well, let's talk about your drums on your Subaru.
All right, sure. Yeah, I sent a set of drums and shoes over here to Scott because one of my cars is a Subaru 360. That's a little micro car. And guess what? I can't go down to the local Subaru dealer and buy any parts for that. Mm-hmm. So here our choice is to simply, well, not simply, but to have Scott do his magic on these, which are a aluminum
what they call Alphen drums.
Alphen drums, yeah.
A cast iron liner and an aluminum drum.
Right.
Yep. So the shoes are all aluminum. Mm-hmm. But what we're going to talk about today is fit. Okay, I have slightly turned these drums. I took about 4/1000ths out of the drums. Okay.
Which I think is neat because, again, we talked about the skill level involved in using a
drum lathe.
And I think that's, you go into a place, I have in the old days, and you hear the lathe just grinding and grinding and grinding away. And by the time you get your drum back, if you hold it up to the light, you can probably see through it. They turn so much material off of it.
Right. Yeah. If you have to find somebody who understands machining, Okay, so this shoe in this drum, I've turned the drum slightly to give a good finish so that the new lining has something to bite into.
Yeah.
And if you lay it in the drum, it hits heavy on the ends and lightly in the middle. If I can rotate that, and there's no rocking of the shoe. It just fits so tight. That's wrong. And I'll tell you why, and I'll show you why in a little bit. But we want the ends not to touch, but the center to touch. And that's what gives you the control, the modulation. And I always explain it like this. If you have a door, and you put your fingers on the hinge side, and you start to close the door, you don't get very far before your fingers are stopping the door from moving. Okay?
Yeah.
You can close the door, but it's going to take a lot of effort.
Yeah.
If you have them on the other side of the door, on the non-hinge side, you can close the door almost completely before that, and then you can press and get the modulation.
Yeah.
And that's what we're doing. We're basically getting you on the far side of the hinge of the door.
Okay.
All right, so we're going to go, and I'm going to take this pair of shoes, and I'm going to set up the machine, and I'm going to arc grind them, and then we'll show you how they fit.
All right. Perfect.
All right.
Okay, so here you can see Scott has carefully measured the ID of all the brake drums and is going to custom arc each pair of shoes to the specific drum.
Okay, I've set up the machine to the diameter of the drum, and now I'm going to run it past the drum, and we will shape the shoe, and then I'll show you how it fits.
Okay.
All right. One. Let's go check the fit. I think that's the lady. All right. See how the ends just don't touch anymore? Mm-hmm. It'll rock, and you can do that with it. That's proper. What that's going to give you, it's going to hit in the center, and as you press, the drum will ovulate to get you full contact.
Right.
And that's what we're looking for, and that's the important part of what we do. See how we can just get that to rock. That's what you want. You want center contact to full contact when you press the brakes, and that will fix most problems with brakes. That and high friction lining.
Right. Right.
Which this is what we call our vintage lining. It's a very, very high friction. It's made for cars that are drum brake only. We have it special made for us.
I think that's part of the, besides the fitment problem, I think that's part of the poor braking performance that we see with ordinary, I'll say ordinary parts store shoes, is the linings just don't have enough friction.
Well, because it's made for modern cars. They use the same lining on all cars. They don't make a special lining just because it's an old shoe.
Okay, so we've got the shoes all arced in now,
Yep.
and the drums are all turned in, so that's pretty much the secret. Want to elaborate on that, any, Scott?
Yeah, the reason we turn the drums, other than making sure they're round and flat, is that they prepare the surface for the new lining. The old lining would be in the drum surface. If you just take a slight cut and get rid of that, it gives a new place for the lining to seat into, which gives you better stopping. The reason we arc grind does two things. One is it helps the break-in period, makes it a lot quicker, and two is it doesn't hit on the ends. If it hit on the ends, it's like hitting a doorstop. It can't go any further, and you have no modulation, and that's that hinge thing I'm talking about.
Right.
So if you hit in the center, which these do, and then you start applying the brakes, the drums actually start out hitting here, and then they ovulate and you get full contact. So if you're just slightly stopping, it hits here a little bit more, and then pretty soon when you're really hitting on it, that's when you get full contact. And that's your modulation that allows you to stop without throwing people through the windshield every time you try to stop. Or worse, scary them because you think you're going to hit somebody's rear end.
Can't stop there.
Yeah. So that's the main thing.
Good.
Find somebody who's old enough to know how to turn these drums without taking any more than he absolutely has to.
Right. I know that I've gone into shops and you hear the old brake lathe going in the back and grinding and grinding and grinding away. So, oh my God, this could be paper thin by the time I get it back.
You know, I had a guy come in and says, I think my brake lathe's bad. I said, why? What's wrong? And he says, well, it locks up halfway through the cut. I said, well, how much are you taking? He says, 50 thousandths aside. I said, 50 thousandths? I said, what are you trying to do? Get it to nothing? So I explained to him that 2 thousandths is 1 mark on that lathe, and I take 2 marks on a cut, so that's 4 thousandths.
Yeah.
That's all you need to take out.
Yeah. Don't take your brake drums to that guy.
No.
You won't have any left.
Yeah, the whole point is that all we're trying to do is make sure we have a surface. We are not trying to make them so that you can do that with 4 thousandths. You don't have to do that with 20. We want these drums to last forever, and they can last forever.
Part of the other, some of the other things that you do is wheel cylinder rebuilding too.
Yes.
So let's take a look
This
at
is off of a 26 Chrysler. It has been sleeved. We sleeve in stainless. The reason we sleeve in stainless is that it's harder. It'll hold up better. Brass is a very soft, malleable material. You get a little dirt in it, you start cutting grooves in the brass, and then you start having leaks. So we like stainless. I don't do it in-house, but I have a guy that's all he does is wheel cylinders and master cylinder sleeving. He's very good at it. That's why I use him. Anyway, this is, like I said, 26 Chrysler. We do everything up to modern cars, whatever needs it. And I think the castings on the older cars are much better. If you look at a casting from a car built in the 50s and earlier, all the iron is very, very dark gray. The modern linings is very, very light gray. There's something missing out of the cast iron that makes the difference. So I would say if I had an older car, I would sleeve them, rebuild them. They're going to last a lifetime.
I would also think the older stuff is also thicker casting, just generally
I
more
don't
to
know.
work with. Or?
I don't know that it's thicker. It's just that it's got something in it that I can't tell you because I'm not a metallurgist.
Yeah.
But it makes it stronger. It makes it more resistant to rust.
Okay. Scott, now I know you guys do a variety, pretty much everything to do with brakes, and that would include the power boosters too.
Yep, this is a vacuum booster. This is off of like an old Chrysler. This is a Hydrovac. They come in many, many different sizes, and this is off of an old International. We do these all the way up to big, medium duty trucks, and we do all kinds of car ones. So if you need it done, we can do it here, and you're going to get your booster back. You're not going to get an exchange, and it's going to be all cleaned up and painted and ready to go. This one looks like it's somebody else rebuilt it, and it needs a little touch up, and we'll get that and figure out what's wrong with it.
Okay. I brought along a couple of special shoes here, and some of our Corvette or Corvair people may recognize these because they were factory options on some GM cars, including Corvairs and Corvettes for a while, and then in the aftermarket as well.
Yep, this is an aftermarket shoe, which we call Velvet Touch lining, and this is an original Delco. You notice that they're little blocks, little pods, and the big problem with these is they come apart. They rust off, they fall apart.
Yep. Certainly had a few of the Corvairs over the years that you take off the drum and there's one of the segments laying in the bottom of it.
Yep. The idea was this is high performance lining, but with high performance lining like this, it's very, very hard to stop when it's cold.
Oh yeah.
You usually end up missing the end of your driveway and the first couple stop signs before you actually get brakes.
Right.
But on the other end, when you were really racing hard or driving hard, they stopped well. So it's a performance lining that I really think General Motors did so they could race, even though they didn't race.
Yes, not publicly, but certainly within the track, everybody knew that Chevrolet was supporting them.
Yes, they made it easier to race their cars.
Right.
Yep. Right. So my opinion is put on something like I put on and it'll do the same job without all the efforts.
Right. And as far as availability of these kind of linings?
I don't think they're available. I know nobody makes this anymore, and Velvet Touch has been out of business since the 80s. Okay. So if somebody has it, it's going to be amazing because they're just gone. They've been gone for years. Okay. So.
All right. One of the things I wanted to touch on was the lifespan of brake parts. I mean, brake shoes, you can pretty much tell by the wear, and maybe they're clean and all, but maybe the stuff that doesn't show too much, like the hydraulic end of it, what can we kind of expect, or what should we be looking at or replacing as parts age?
Yeah, well, there's certain things that should last forever, so to speak. People ask me, how long do hydraulic parts last? Well, it depends. How long does the motor last? Well, if you change the oil, it lasts a lot longer. And most people forget to change their brake fluid.
Right.
2 years is the maximum life of brake fluid. At 2 years, it's 20% water, and water deteriorates brake systems. So if you change it like you change your oil, your hydraulic system should last for years, years and years, except this little gem.
The brake hose.
The brake hose. The brake hose does a lot for you, but it actually will break down internally after 10 years. It starts to deteriorate. So my suggestion is every 10 years change your brake hoses. Some people I know, they say, well, I've still got the original hoses from 1968. I'm so happy. Well, until they blow. So brake hoses 10 years. The rest of the system can last you the life of the car if you keep changing the brake fluid.
Speaking of the brake fluid, is there any practical advantage to using the silicone brake fluid over the Dot 3?
Some people like it. I'm not a fan. And the reason I don't like silicone brake fluid is it doesn't lubricate well like Dot 3 does. And they say, oh, but it doesn't absorb moisture. Yes, but you still get it through condensation. So you still have to change it. It's expensive. We got a story here. One of the companies in town read about silicone brake fluid, ordered a 55-gallon drum.
That's a lot.
They changed all the brake fluid in all the cars. Within 2 weeks, all the cars had seized calipers and master cylinders because silicone brake fluid doesn't work well with some rubbers. Okay. So a lot of people like it because I never have to touch it. No, don't believe that story. It's like lifetime motor oil. Doesn't work.
It's the life of the oil, not the components.
Yes, correct.
Okay, one thing I'll just add that, you know, we talk about deteriorating brake hoses. I mean, it's pretty obvious if the hose gets cracked, you know, especially right near the fitting where it has to bend and all. But what's less obvious is the deterioration inside where the hose collapses and it turns into a one-way valve.
Yes, absolutely.
So Scott, on the sleeving, we saw the one wheel cylinder that was done. Do you also do the masters?
Absolutely. Do brake masters, clutch cylinders. We even do on boosters, some of the hydraulic ones we end up having to sleeve. So yeah, full range on that.
Great. Scott, I know when I pulled up, I saw various service bay doors in there. Do you actually do customer brake work?
And we don't do work on the vehicles. We only work on the parts. We sell to a lot of garages, and so we don't really want to compete with our customers.
So Scott, how many employees you got working here?
Well, basically in the shop, it's me.
That's it. So if somebody calls up and says, "Hey, I got this problem," they're going to end up talking to you.
I answer the phone 99% of the time, unless I'm super busy.
And I'll vouch for that. I'll vouch for that.
Yep. Unless I'm super busy, my wife might answer, but yeah, you're going to get me.
Okay. And just about coverage, we've been talking about the stuff we've been doing, and obviously you do some foreign car work because you've been instrumental in keeping some of my collection of oddball imported cars going. But what kind of coverage do you guys do?
Oh, we do almost anything. If it has brakes, we probably have done it. We do everything from go-karts to cranes. We do foreign cars. I just had a couple Maseratis in here last couple weeks from the 50s. One of them Fangio drove, which is kind of cool.
Oh, cool, yeah.
Yeah, so you just never know what's going to come in the door.
That's really a key factor in getting a good brake performance. Like I say, if you just go ahead and buy some parts store stuff and put them on, you might be disappointed at the amount of effort it takes to get the car to stop, because you're thinking, I got everything new on here and it should stop great, and it often doesn't. And the key is to getting the right kind of friction materials on the shoes. And pretty much at the parts store, you don't have an option with that. You got whatever they have available, period. And then also importantly, to get the surface, the shoes arced to match the drums, so that you've got the right contact from the first stop. And that makes a huge difference. You saw them doing my little Subaru, and the first time I took it around the block, it felt like I had power brakes. I mean, it was just unbelievable, the difference it made. And so that's why I go to Scott. Now, Scott isn't the only guy in the world that does this. There's probably other brake shops out there. And there's certainly places that reline shoes. So you can get your shoes relined, but are they going to have the right material? And even if they do they have the capability of micro cutting the drums like Scott does, and to also arc the shoes to the right fit? So those are all questions you have to ask if there's a local, brake specialist. And, that's what we all used to do in America, was reline brake shoes. There are places all over the place. So this is kind of a holdout, but it's worked really well for me to get the stock brakes working, like they should, like they used to when they were new.
Hey, Larry, just while we're on the subject of what he just said, someone did put a question about there, but how often do you change the brake fluid? He talked about changing brake fluid, but how often?
Well, Scott says he recommends to change the brake fluid every 2 years. That was kind of surprising to me to do it that often. Now, generally speaking, almost every car, unless it's in an extremely good environment, is going to need brake service by 10 years anyway. You're going to get leaky wheel cylinders, you're going to get stuck wheel cylinders. Certainly brake hoses are a concern. We've had numerous examples at conventions and everywhere else of people coming and, all of a sudden they're, one wheel is on fire basically because the brake hose has collapsed internally and it won't release. You don't have your foot on the brake, but that one brake is still stuck on. It's because the brake hose turned into a one-way check valve. And, anybody who's got original brake hoses on your car, well, that's great. Take those off and put them in a museum somewhere, because they're not any good on your car. They're just waiting to cause you problems. So Scott's saying every 2 years. I mean, they're in the business, and I'd have to kind of go by what he says to change them, to the fluid. Certainly the brake hoses, most people overlook those. And on brake lines, if you're doing a restoration, now it's time to change the brake hose. If you're doing a gas tank on your car, now's the time to change both the front brake lines. The right front is impossible to change with the gas tank in the car. You got to have it out. you can change the left front with it in the car. It just makes it easier if the tank is out. So if you got tank out for any reason, change those two front lines. They may look okay in certain parts, but especially where they go through the rubber grommet at the toe board and at the wheel houses, the lines get rusty under where the grommet is. So, just because it sort of looks okay, the lines are cheap. You can buy pre-bent lines, which I recommend. They cost a little more money, but man, are they easy to put in. And especially when there's a lot of tight little fussy bends, it's hard to do that and make them get to fit really well. Get the pre-bent lines, put them in, and it's okay. If you're doing the one in the tunnel that goes from the front to the rear, that's a tricky one because it's very long, and those lines were installed before the rest of the car got put together, and you'll see why when you go to change them. That back one's got to get around the rear cross member and the wiring harness, the fuel line, everything. It's tricky to get that in. You'll spend a little time. No, you'll spend a lot of time getting that center one in. But you do it, and it's going to be good for as long as you're still driving. So I would recommend that. And speaking of preventing failures and stuff with lines and hoses, let's take a look here at one more thing that a lot of people do, and it's not a bad idea. And that is, here we go, a dual master cylinder conversion. Okay, so a lot of people do it. There's kits available to do this. I'll just make a couple little comments on it. And one is when you are drilling the hole for the other line that you're going to put in, okay, make sure you take a good look underneath the dashboard what's there, because in that same area of the brake block where they all come together, there's a lot of stuff going on underneath the dashboard. You got the other brake lines, you got the parking brake cable, you may have wires and stuff underneath there. So double and triple check before you drill that other hole for the line. And the other thing, as I explained earlier, is to check the push rod of your replacement master cylinder. Now, you don't have to absolutely positively use a Corvair master cylinder. There are some other ones that you could use, but in any case, you always want to check the free play of the brake pedal so that you have the right amount of clearance so that the cylinder can return all the way. And one thing about a dual master cylinder, and I don't care if it's a factory installed one or one you put on, and that is how the dual master cylinder works. I'm going to take this great illustration from my nice old Bendix brake master catalog here. This is an inside view of a dual master cylinder, and you see you got the two chambers with the two sets of cups and springs. If one chamber loses pressure, so let's just say that a wheel cylinder falls apart, your brake drum fell off, and the wheel fell off, the brake drum falls off, you step on the brake, the wheel cylinder expands enough, pops the pistons out. Now you have no brakes on that one end, or for any other reason, line failure, hose failure, whatever. Normally, one chamber, here's our push rod, they both got fluid in them. As this one starts to get pressure in it, it now starts to move the second piston. They both equalize themselves out with the same amount of pressure, and you have pressure on both sides. If we lose one side, there's nothing to keep the first side from moving all the way in until it physically contacts the second chamber and starts to push it. Now, what that means is your brake pedal is going to move about halfway down before it contacts the second chamber, and you start to push it to activate your remaining brakes. What's important to remember about that is if you don't have the brake shoes adjusted properly, if your brake pedal goes down to half of its travel on normal brakes with everything working, guess what happens? You're going to run out of travel on the brakes before you get that car stopped because you simply don't have that much travel. You simply don't have that much travel in the brakes anymore. And you have to have the brake shoes adjusted properly for the dual master cylinder to work. That's the basic of it. So a dual master all by itself is not going to save your ass. You got to have the rest of the brake system working okay, and especially the shoes adjusted properly. That pretty much, we wanted to see if we can get some pictures of customer mistakes. I used to take pictures of stuff that came in that I looked at and shook my head. And so let's see if we can just show you some of the bad things that people did. Here's one. If you can see this, I'm going to take a look. That's an early model that somebody has replaced the brake lines on, and I've got the tonneau cover off next to the gas pedal, and you see that nice gentle curve of that brake line coming out of the block on top. It goes around and goes right over the clutch cable and the parking brake cable, which are sawing a hole through the brake line. So there's one for homemade brake lines. What's our next one? This car came in with a compression coupling on the rear brake line. Remember, I was talking about it being kind of difficult to replace that line from front to rear. Well, this guy said, yeah, you're right. That's a lot of work. I'm just going to put in a little section here, and I'll just use this compression coupling. Well, one test I always did and still do on my cars, I call it the harder test. I get in and I stomp on the brake pedal real hard. And when I think I stomped on it as hard as I can, I grab hold of the steering wheel and stomp on it as absolutely hard as I can. And if nothing happens, then it's okay. The brakes are working, all the lines held up, everything's happy. And on this case, on this car, it failed miserably because I didn't have to step on it real hard, and it blew that compression coupling right apart, and it had zero brakes. So never, ever, ever use a compression coupling on a car. But here I had a late model come in that somebody put a disc brake conversion on it. And when I got underneath the dash, I couldn't believe my eyes. Yes, they put a disc brake conversion on, and they used compression couplings to put the lines together. Couldn't believe it. Here's another one where somebody did their own homemade brake lines. Again, the parking brake cable was sawing away on that one brake line there, soon to have a hole in it. Here's another one on a different car. Again, same type of deal. They ran a different brake line. They put the line on the other side of the clutch cable, left the grommet out, but still managed to get it so that the clutch cable was working its way through it. And here's another one that came in, early model. And as you can tell, they simply neglected to install the retainer that holds the brake hose onto its bracket. The thing was just dangling by the brake line, surely to fail because it would, it's going to cause the brake line to keep flexing. Okay, that was all of those. So that was fun. I think we had another album. Did we, Shells? Yeah. Okay, we've got a few more things that customers, and I imagine some of them came from repair shops like that too. Here's one. Now that all looks quite normal. Okay, except that's the right front corner of the car, and you can see the brake shoes are on backwards. They've got the short shoe facing the back of the car and the long shoe facing the front, which is backwards. So they must have looked at the shop manual, decided, yeah, that's okay. Now this guy did something a little bit different. He apparently didn't pay any attention whatsoever that there was a short and a long shoe, because he managed to put both long side ones on the same side of the car. And yes, in fact, both short ones around the other side. And yes, the car had a brake pull to it. Imagine that. Here is another one that, again, another different car with the short shoe on the back side and the long shoe on the front. I got those in all the time. People are always getting them wrong. And let's see, this one, I'm taking a look. Yeah, same thing again. This one's an early model, and it's got the brake shoes on wrong again. Short ones always to the front. So that was just some of the common problems we had. I also had a lot of problems with people who tried to cheat on putting on wheel cylinders. And by cheating, I mean, they took off the screws that held the wheel cylinder to the backing plate. And instead of trying to break the line loose at the hose, they decided, I'm just going to pull this wheel cylinder away from the backing plate and spin it off and spin the new one on. And that way I won't have to mess with the brake line. I don't want to strip that brake line fitting. So they bolted all up. Well, guess what? The thread doesn't always start in exactly the same place. So the brake hose ended up being twisted after they tightened it. And of course, that's a problem. I've had them like they're S-shaped. They would rub the suspension because now the hose is not routed properly. It shortens the effective overall length of the hose when it's twisted. Lots of times I had, people had poorly done brake jobs. Very dangerous. So I guess I'm open for questions if anybody's still out there. And I seem to have this problem of always running late.
That's all right.
I apologize.
We had quite a few questions in chat, but I believe you covered quite a few. I will just touch on one or two. Here's one, probably good example. I replaced the brake shoes on my 65 four-door and the brake pedal is still low. Any ideas?
Well, yeah, first thing is to adjust them like I showed. If you just threw them on and thought the self-adjusters were going to fix it, forget it. You have to adjust them yourself manually, and you got to go all the way until they lock the wheel up and then back it off a little bit. Because if you just turned it until it had a little bit of a drag, the shoes were probably not centered. Yeah, it had a little bit of drag on one shoe and the other wasn't even close to touching. So that's the first thing, is to properly adjust the shoes as I showed.
Okay. Here's one too. Could you comment on front rear brake balance on late models? It seems that my rears, particularly the right rear, seems to lock up before the fronts.
Okay, well, generally speaking, you probably want the rears to lock up before the fronts, but they've got to do it evenly. Okay, if you've got one wheel that's locking up before the others, then there's a friction issue with that wheel, or it could be the other side. Maybe that one is working properly and your left rear isn't. Okay, so that's a situation where you'd want to have inspect both rear brakes. I would if I really wanted to fix this, I would get the shoes relined with the proper kind of material, like we showed in the video, and the drums properly turned, and then adjust it all. Make sure you got good hoses on there. If your hoses are more than 10 years old, get rid of them, and then adjust everything up, and you should be fine. The reason you want the rears to lock up slightly before the front is because if the fronts lock up first, then you lose your steering. You're not going to be able to steer your way out of a bad situation. And I don't want to talk about disc brakes because that's not what this thing is about, but because we're talking about balance here for the people who are thinking about doing a disc brake conversion. Now, the disc brakes have advantages, don't get me wrong, okay? But you're taking, basically, you're taking a disc brake system from a different kind of vehicle altogether, and almost all of them are going to be front engine. On the late model Corvair, a popular conversion uses the S10/Toronado Eldorado style drum and caliper and such, and adapts to the front of the Corvair. Well, those vehicles are much heavier than a Corvair, and they're also front engine, which the front brakes do a lot more work. You put one of those front disc brake kits on the Corvair, and you have just changed the balance of the brake system significantly. Now you got way more potential stopping power on the front than you do on the back. And that's a situation where you'll probably have to put on a proportioning valve and spend a lot of time screeching your tires trying to adjust that thing to where the fronts won't lock up first. Because if you don't do that, if you step on the brakes hard, your front wheels are going to lock up really good with those good disc brakes, and you're not going to be able to steer. So balance is important.
Okay, good one. let's see, how bad is it to have pitting?
How bad could it possibly be?
How bad could it be to have pitting on the inside of the wheel cylinder?
Well, it's going to cause leaks. That's the problem is when you get a pit inside there, the wheel cylinder cup can't seal that leak, and you're going to be losing brake fluid through that wheel cylinder, which is eventually going to get on the brake shoes, and then that's going to kill the brake shoes. It's going to make it pull real bad or not stop. Well, you got two choices. You can either replace the wheel cylinder. All the wheel cylinders for the Corvair are reproduced. Get them through Clark's because your local parts store is not going to be able to get them. And you can do that. They're cheap. They're like $25 a piece. Why would you not do that? So replace the wheel cylinders, or if you want a longer term solution, you can get them sleeved. You can get them stainless steel sleeved, and then they can't pit. But yeah, if the wheel cylinders are pitted, get rid of them. Either get them rebuilt or replace them. That's an easy one.
Sure.
And you ought to be doing that. Like I say, 10 years is about the time you got to get into a brake system and do some major work, typically on most cars, that haven't, been sleeved and everything else and properly maintained. Hoses, wheel cylinders, that sort of stuff. A lot of my cars have been sitting for the last 8 years or so. And that's all I'm doing. I'm doing brakes every single day on a different car. Same things over and over and over again.
Well, again, thank you, Larry. Thank you, Shelley. Thank you, everybody. Have a great rest of the month.